The heavy-duty ball winder uses a friction drive system. Friction drive meaning, of course, we have the handle that's turning the arm. That's not what I'm referring to. What I'm referring to is this O-ring that goes around the gray flange. As we rotate the handle, that rubber O-ring is causing the spindle to ever so slowly go around in a circle. And it takes about 12 to 20 turns of the handle to get that spindle to make one complete rotation. Now, why do we use a friction drive? We use a friction drive because there's no belts, there's no gears, no pulleys. All there is friction, and that's created by the O-ring pressing against that steel shaft. That gives us a guaranteed rotation effect, provided that we're not so tight on there that the friction is so high that the spindle can't turn. So if that were really jammed on there, you really couldn't turn it. So as you can see, this amount of friction is fine. Because this is not turning really fast, it doesn't need to have super low friction, but it also doesn't want really high friction either. High friction would be created by way too much pressure with the O-ring against that shaft. So if I jam that down there really hard, which is what some people do, you can't turn the spindle. And when you can't turn the spindle, you get a wonky ball. So our objective is to lightly contact that shaft, but if you just lower it until the O-ring hits the shaft, that's how it should turn. It's just very, very easy concept. Once you get the hang of it, it takes about 20 seconds to make that adjustment. And it will work each and every time, no problem. We're going to demonstrate how to position the O-ring on the ball winder. And I'm going to start by having a situation in which the O-ring is clearly too tight against that shaft. And the shaft we're talking about is that shaft right there. Okay, the shaft that protrudes up from the center of the ball winder. So, as you can see, I can hardly turn that spindle. It won't turn hardly at all. It's really tight. It could even be tighter, which would be even worse. But it's really tight, and when it's that tight, when you turn the crank handle, chances are, even though the slot may turn around, because we're watching this slot up here turn around on each rotation, it'll be delayed, and when it's delayed, then the ball will get screwed up and it won't be proper. It'll be a wonky ball. So all you have to do when that situation arises, and it can arise for a number of reasons, but and I'll explain that in a moment, but basically all you do is loosen the two screws, just a quarter turn. You don't have to mess with them very much. You set it right back down. As soon as the O-ring touches that shaft, you tighten two screws. You see how easy it is to use with this nut driver, by the way, as opposed to a screwdriver where you're having to get in there and find the slot. That's a real pain in the neck to do that. So invest in a $5 nut driver at Home Depot. It's a 5/16 inch nut driver. Really super easy tool to use. And it will pay itself back in no time at all, just because when you have to make an adjustment, it'll just make it simple. So you notice now how easy it is to turn. I can do it with two fingers. All I did, quarter turn, loosen them up, take it off, put it down, support it now, don't leave it go. As soon as it hits that steel shaft, while you're still holding it, tighten the two screws, and there you go. That's the only adjustment you ever have to make with the ball winder, with one minor exception with this collar, and I'll show you that in a moment. If you're curious as to where the O-ring on the spindle flange, this is the flange, this gray material, this is the spindle, this is the O-ring, where that should hit the conical shaped shaft, which is that steel shaft coming up out of the ball winder, it should hit about 2/3 to 3/4 of the way up the slope. It should never ride on the very tip of the shaft. The closer you get to the shaft tip, the spacing on the ball, the strands of yarn on the ball will be closer together. Now you're not going to be able to fine tune that. That's pretty much a function of all the different parts that we have to put together. But we designed the product to give you about a 3/4 up the slope fit. And generally that's going to give you between 1/8 and 1/4 inch spacing on your strands of yarn, roughly speaking. Okay, sometimes they could be a little smaller, sometimes they could be a little bigger. But whatever they are, that's a function of how far up the slope you are. And what you're trying to achieve again is the easy movement. See how easy that is for me to move? That's the proper tension on the O-ring. Any tighter than that, you're going to run the risk of getting a wonky ball. And that will also affect motor operation. If you've got our motorized unit, if you've got that O-ring too tight, that'll put a tremendous load on your motor, and your motor at some point could even slow down and stop. It's similar to putting an 80-pound knapsack on your back and walking up a flight of stairs. If that O-ring is too tight, that's like trying to go up those stairs with an 80-pound pack on your back. So you've got to make sure that load is not there, that the O-ring is not too tight, and that will make everything work as designed, no wonky balls and no motor problems. Now normally when you make that adjustment that we just did, you would remove the collar. Take it right off. Because if it's jammed up there too tight, it'll restrict the motion. So it's a good practice just to remove the thing. Now you'll see as I slide that back down, more than likely it's not going to find the right spot. What we have to do is once again loosen 2 screws, 1/4 turn, lift it off, set it back down. As soon as it hits the shaft, tighten the 2 screws. And there you go. Now at this point we would put the O-ring back on, or the collar back on. Now after you've set up the proper position of the O-ring, you can tell I'm turning it now, no problem. Now's a safe time to reposition the collar. So you just put a business card under the wooden arm, push the collar up there so it's holding that snug. That creates a gap. That creates about a, I don't know, 64th of an inch gap. Pull the card out. So there's a little gap there. You don't want it too tight up there. And it prevents you from pulling the spindle off when you're removing the yarn. That's the whole purpose of that collar. Okay? In fact, it could be up there a little bit snugger, but it's perfectly fine where it is at this point. And you can see we're turning that. Even if I pull it as I'm pulling yarn off, it's not going to go anywhere. It's still going to maintain its same position against that shaft, which is what we're trying to achieve here. Another thing that users typically do is they forget to adjust the curly Q on the tensioning post. That's this curly Q right here. About 1.5 years ago, we added a black knob on the base of this post that allows the user to change the position simply by loosening it, turning it, and retightening it. And you'll notice now I've got it about 45 degrees off of center, and it's not aiming straight at the spindle. If you aim it straight at the spindle, whoops, as the yarn comes in, there's no tension being added to the yarn. And also you're not calming down the yarn as it comes from the swift. Oftentimes coming from the swift, it's shaking all over the place, the yarn. And that disrupts the ball. So if you can control the vibration on the yarn, which you simply do by loosening that knob, turning this about 45 degrees. You can even turn it 90 degrees if you want. If you have to add a lot of tension, bring the yarn in through here, have it exit there and go to the ball. You'll be putting quite a bit of tension on there. But some yarns require that tension. So anyway, that's the way you use that post. It's very key. It's a fine adjustment, and I encourage you to use it. 45 degrees is about the right position.